Welcome to this video. In this video, we will see how to simulate a three-phase sine PWM based inverter. So the circuit diagram is given here. So we have a three-phase bridge arrangement here. So the input to the three-phase bridge is 500 volt DC. Then this three-phase bridge has three legs, and each leg has an upper switch and a lower switch. The switches are numbered like this. Then the midpoint of each leg will give you the output node. This is node A, this is node B, and this is node C. From these nodes you can connect an LC filter like this. So in each phase a 50 millihenry series inductance is connected, and a 5 nanofarad shunt capacitance is also connected. So this forms the filter part. This is an LC filter. Then the filtered output is fed to an RL load with a resistance 100 ohm and a inductance 1 millihenry. So this is the circuit setup. Now we have to generate the control signals also to switch the turn on and turn off the switches properly. So we are using sine PWM. So in sine PWM, we will have a modulating sine wave and a carrier signal. Okay, so we will have a modulating signal which is a sine wave with a maximum amplitude 1 and a frequency 50 hertz, because the frequency of the modulating signal will be equal to the output frequency required. Then this is a carrier signal which is a triangular wave. This can be generated using a repeating sequence block in MATLAB. Okay, then we will compare the sine wave with this triangular wave, and if the amplitude of the instantaneous value of the sine wave is greater than the instantaneous value of the triangular wave, then we will get a high output, and that is fed to switch number 1. And switch number 4, which is the bottom switch in leg A, which will be receiving a gate pulse that is equal to the complement of S1. So we will note the output of this comparator. A NOT gate is used, so that output is given to S4. Like that we can control S3, S6 and S5, S2. Okay, so the similar structure is used in other legs also. Only difference is the modulating signal phase will be shifted by 120 degree in the case of second leg, and again it will be shifted by another 120 degree in the case of third leg. This will be clear when we do the simulation. So let us go into the simulation exercise. So first you can take a blank SIMULINK page. Then we will place the components first. So the first component is the DC voltage source. So that is placed on the left end. Then we need MOSFET for simulation. So MOSFET is taken. Then you can rotate the MOSFET so that drain is on the upper side and source is on the lower end. We need such 6 MOSFETs. So take copies of this. So in each leg you have 2 MOSFETs. There are such 3 legs. So this will form the bridge. Then we have an LC filter on the output of the bridge. So series RLC branch can be used. Search for series RLC branch. So you will get a series RLC branch, and make it L, branch type L, and enter the value also so that you can take copies of this. The value is 50 millihenry. So then take 2 more copies of this. You can just right click and drag to take copies. Then take another copy of this inductor and change it to capacitance. Branch type into capacitance, and you can make the value 5 nanofarad, 5 e minus 9, 5 into 10 raised to minus 9. Okay, then rotate this. Then take 2 more copies of this. Okay, now we need RL load. So you again take a copy of this inductance. Okay, make it RL type. then enter the value of resistance as 100 ohm, inductance 1 millihenry, 1 millihenry. Okay, then you take 2 more copies of this. Now we need a ground.